All right, next we're going to look at how to find the length of a line segment using the Pythagorean theorem. So the first thing you might see is something like this. We're given a graph and it's got part of a line on it, and we are to determine exactly the length of this line. So here's the way that we do this. We're going to take this and we're going to turn it into a right triangle. So the first thing we do is start at whatever your highest point is and draw a line coming straight down until it reaches a point where it matches the lowest point on there. And then take those and connect them that way. Every grid spacing on this always meets at a 90-degree angle, so by just lining these up this way, we've ensured ourselves that we have a 90-degree angle. And so now what we can do is we can actually find the distances for these. We can say that this is a right angle right here for sure. And we can find A, B, and C by measuring them on the graph. So let's take a look at this side, which I'll call A for starters. It is 1, 2, 3, 4, 5, 6 units long. B would be this side. That's 1, 2, 3, 4 units long. And then C, I don't know. That's what I want to measure. So what I'll do is I'll use my Pythagorean theorem, a squared plus b squared equals c squared, and substitute in what I know. I know that is 6, I know that's 4, and I don't know what that is. So this is going to give me 36 plus 16 equals x squared. Now I just need to add those together, and let's see, that would be 52 is equal to x squared. Now, what I need to do with this is to actually simplify that as much as I can. So just as before, when I go to simplify this, I've got to simplify the square root of 52. Let me slide this up here so we've got some room. So I know that x is equal to the square root of 52. Now I'm going to take that and simplify just as I did before. So I need a factor tree for 52. And I can tell you that 52 is 4 times 13. 4 is 2 times 2. 13 happens to be prime. And so when we move this to the outside, we're going to get that the square root of 52 is equal to 2 times the square root of 13. So I can come down here and I can rewrite this and say that x is equal to 2 times the square root of 13. And if you'll recall, x was the length of this line. So by setting this up as a right triangle, I've actually found the, excuse me, I lost track of thought there. I've actually found the length of that line segment, which is what I was aiming to do. Alright, now I've switched and gotten myself some fresh paper since I marked on all of that. Our next task is going to be to find the distance for this. Now in order to do something like this, where we're not given a graph, we need to find A, B, and C. Here's the setup for this, and you can actually draw this out on the graph and use this method, which will work just fine, or you can be kind of clever and set it up this way. Our hypotenuse is always going to be our unknown, and so what we need to do is, in order to find A and B, take whatever your biggest x value is and subtract your smallest x value from it, and that'll give you A. -1 is bigger than -5, so I take -1 minus -5. So -1 minus -5, that's the same thing as -1 plus 5, so that tells me that A will be 4. For B, I take my biggest y value and subtract the smaller one, and so I know that B will be 3. So again, to find A, I took my x values, took the bigger one minus the smaller one. For B, I took the bigger y value minus the smaller one, and C will be x. And now it's just a matter of setting up the Pythagorean theorem. substituting in what I know that A is 4 and that B is 3. And so what I'll get is 16 plus 9 equals x squared. Give ourselves a little room to look at this. So that means that 25 equals x squared, and when I take the square root of both sides, I'll find that x is equal to 5.